Assalamualaikum and good day everyone again. We're continuing with our part 2 for chapter 4. We are looking now for the mean of discrete random variable. Any distributions we will need to have mean and also standard deviation. So firstly we look at the mean first. Now mean, which is also, you can call it as average. This is what you expect to repeat, okay, if an experiment is repeated for a large number of times. So this concept of mean or average, you have done this in your chapter 2 also. So please take note of the symbol of mean here, your mu, but in this case, since we are doing for the probabilities as well, so you need to find for the mu by looking for summation of your x and multiply with its probability. So summation means again total of your x multiplied with its probability. So please take note, we also call your mean or your average as expected value, and we use this ex to represent the expected value. Okay, next part is the standard deviation. Standard deviation is used to measure the spread or dispersion, the spread of its probability distribution. And of course this is your standard deviation symbol. Now please take note, this is of course your variance, alright, and if you want to find for the standard deviation, you need to find the square root. So in this case here, this is where you have to change your x into x squared and then multiply with its probability, alright, and then you also find its summation again, and then you have to minus the square of its mean or average. So the higher value of a standard deviation, it means that your x can take over a large range around the mean, meaning that the data values are not so far from the mean, okay, they are not so dispersed. If you have a smaller value for your standard deviation, means your values are clustered closely around the mean, okay, so they are not far from the mean, they are not so dispersed. Okay, let's take a look at example 5. You are given here the probability distribution straight away, so please take note, you have the table here that is also called your probability distribution of car sales per day in a used car dealer based on past data. So your px is referring to the probability of your x here, and you need to find the expected number, expected value, which is also your mean, and you need to find the standard deviation. So using the previous formula for mean, okay, again ex is your expected value or also your mean. So in this case, expected number of sales per day. Using the formula, again find the summation of your x, multiply with its probability, and since you already have your x, so you multiply with its probability. So 0 times 0.1, and then you add with 1 times 0.25, and then you add again with 2 times 0.3, and finally you add also for 3 times 0.35. So altogether you get exactly 1.9, okay, that is your mean. But since we are talking about number of sales, so approximately there have been on average there have been 2 sales per day, right? So that is your expected value. For your standard deviation, please take note of this formula here. This is different from your mean, of course. This is your variance. You have the symbol here, it refers to your variance, and then later only you find for the standard deviation. So you start off by finding the square of your x, alright. So 0, of course you square, you still get 0, and then multiply. Okay, take the square of your 0 and then you multiply. 1 square when your x is 1, and then you multiply, and then 2 square, multiply. Okay, 2 square, of course 4, then times with 0.3. 3 square, okay, 3 square you get 9 times your 0.35. So you do accordingly for each of your x. And then later you need to minus the value of your mean. Okay, so in this case you need to take the actual value. So just now we got 1.9 exactly, and so you're using back that value. So altogether you get 0.99 for your variance. To find the square root, to find the variance, you need to square root for your variance. So finally you get your standard deviation. Okay, another way for you to calculate for the mean and also your standard deviation is to come out with this kind of table. Alright, this is not in your notes, so you may need to copy this down. So you do accordingly. Of course, you already have for your x and your probability. Okay, this is similar to what had been given to you. And then the third column here is where you have your x multiplied with your probability. So x multiplied with the probability, you get the value. So 0 times 0.1, you get 0. 1 times 0.25, again you get 0.25. 2 times 0.3, you get 0.6. And finally 3 times 0.35, you get 1.05. Okay, and don't forget, always check for your probabilities. You always need to have 1 for the total probability. Okay, for the third column here, okay, you're going to need this later, 1.9. This is also your mean, if you still remember. This is also your expected your expected value. Okay, your mean. And it's better for you to produce for this fourth column, if you really need, your x square, so that later on in your fifth column here you can have x square multiplied with your probability. So add all. Okay, you're going to use this for your standard deviation. So check back, and of course you just need to substitute. Okay, mean is already 1.9 from your third column here. Okay, your 1.9 from your third column. And then for your standard deviation, okay, there's supposed to be a line over here. Right. So you take 4.60. Okay, and then you have to minus with the exact value of your mean, so 1.92. So lastly you get 0.995 for your standard deviation. So this is a much safer way for you to calculate for your mean and your standard deviation, because you construct everything in the table and then you can see clearly one by one. Okay, example 6 here, you are given again probability distribution. You want to find the expected number of source rented per day and also to find for the standard deviation. You're given this probability distribution. Alright, so construct for your expected value, which is also your mean. So you can calculate directly. Okay, you do for your x 0, you do when your x is 1, and also when your x is 2, and finally you get the actual value of your mean is 0.67, which is approximately 1. So on average you can say there's only one chain rented per day. And second part is to find for your standard deviation. Alright, so easy way is of course to find for your variance first, and then later only you find the square root of your variance to get for your standard deviation. So this is similar to what you had done previously in example 5. Okay, you find one by one. Okay, find for this one first, and of course don't forget to minus with your actual value of your mean. Okay, this is again your expected value, square of your expected value. So lastly you get your standard deviation as 0.7491. Okay, this is another way for you to find your mean and standard deviation by using the table. Construct the table so that you can do your calculation in a more organized way. Okay, similar, same, only in a form of table here. Okay, same goes with the previous example. You have your construct for your xpx, your x squared, and your xpx. And finally, you should be able to get the same values for your mean and standard deviation. Okay, I stop here for our second part. Next, I will continue with cumulative distribution function.